Hello, welcome back to Maths Mastery with Benjamin. Of course, we make maths simple and fun. So today we are continuing with our set and operation on sets. We'll be looking at the Venn diagram. So before we start, kindly like, comment and subscribe to my channel for more maths mastery. Now let's begin. So the Venn diagram is a visual representation of set problem. So in case you have any set problem, any set question, and you want to represent it in a diagram form, that is the Venn diagram. How do you go about it? So let's look at how to solve set problems using the Venn diagram. So I'm going to take you through three various set problems, and the first I can talk about is the one set problem. We have the two set problem. Lastly is the three set problem. So now let's take them one after the other. So now the one set problem. So one set problem is when you've been given only one set. So how do you represent this in a Venn diagram? So this is how our Venn diagram is going to be. So we have a nice rectangle here. And this is the set. So I'm going to label this diagram here. So this rectangle here is the universal set. Normally denoted by number of u. So this is our universal set. So the rectangle here represents our universal set. So everything within the rectangle should be equal to the universal set. Now the circle here is the sets we are talking, the one set we are talking about. So this set, let me denote it by A. So let's say A. So this circle here represents the set. So the universal set contains the set. So everything within the rectangle should be equal to the universal set. Right? Okay. So this area here represents the elements that are in the universal set but not in the set we are talking about. So this becomes A complement. The area here becomes A complement, which represents the elements that are in the universal set but not in the set we are talking about, which in this case is set A. So the elements that are in the universal set but not in the set given, that is set A, is called an A complement, right? Okay, so this portion here represents the elements that are for A. So the elements that are for A, and outside the circle is the elements that are in the universal set but not in A, as I said earlier on. So that is it. So we can say set A, that is number of A plus number of A complements, should be equal to the universal set, right? So the number of A plus the number of A complements should be equal to the universal set, right? So yeah, that is the one set problem we are talking about. So let's solve some example under the one set problem. So we have this question here under the one set problem. So in a class of 42 students, 30 like mathematics. Draw a Venn diagram for this information. Hence, find the number of students who do not like mathematics and the percentage of students who like mathematics. So now let's solve this. Now let's represent our information in a Venn diagram. And it is going to be like this. So now we have the Venn diagram here. And our universal set is going to be the total number of students in the class, which is 42. So we have 42. And the number of students who like mathematics, I'm going to represent it by n. So number of n is going to be 30. So 30 students like mathematics, right? Okay. So now this is the Venn diagram. So we represented the information in a Venn diagram, and this is how it looks like. Now let's find the number of students who do not like mathematics. So add the number of students who do not like mathematics. And it's going to be the number of students in the class, which is the universal set. So we say number of u minus the number of students who like mathematics. That is the number of n. And that is going to be 42 minus 30. And that is going to give us 12. So we say 12 students do not like mathematics. Yes, and that is it. So we are now with the first question, the number of students who do not like mathematics. And it's going to be the number of students in the class minus the number of students who like mathematics. So I represented the number of students in the class by U, which is the universal set, minus the number of students who like mathematics, which is the number of n in the Venn diagram here. And we are going to get 42 minus 30, and we are getting 12. So we conclude that 12 students do not like mathematics. So now let's solve the second question, the percentage of students who like mathematics. Now the percentage of students who like mathematics is going to be the number of students who like mathematics, that is number of n, right, divided by number of students in a class, which is the universal set, times 100, right? And this is how to get the percentage of students who like mathematics. So we say 30 divided by 42 times 100. And that is going to give us 71.428%. And that is the percentage of students who like mathematics. So now we move on to the two set problem. I believe it is clear now. So there is a one set problem, and it is very simple. And I believe you understand the one set problem now. So let's move on to the two set problem. So the two set problem is where you've been given two sets. And how do you represent this in a Venn diagram? So to represent two set problem in a Venn diagram, this is how it's going to look like. So we have our lines, rectangle here. And in this case, the circles are going to be two because it is a two-set problem. So this is the Venn diagram, and the rectangle here, of course, it is our universal set, so number of u. So the rectangle here is our universal set, and this is the sets given. So let's denote one circle by A, so number of A, and the other by B, so number of B. Now this is the Venn diagram of a two-step problem. So I'm going to explain this diagram. So let me represent this portion here by 1, 2, 3, and then 4. So the portion which is labeled 1 represents the elements that are for A only. So 1 represents A only. And the portion here 2. So 2 represents the element that are for A and B. So the intersection of A and B, right? And that is going to be A intersection B. So the element that belongs to A and at the same time B. That is the portion labeled 2. Now 3. So 3 is for B only. So the portion here represents the element that are for B only. So B only. And the last one, which is 4. So the area here outside the circles. So the area outside the circle, which is labeled 4, represent the elements that are in the universal set, but not in these two sets. And that is going to be A union B complement. Right? So the element that are in the universal set, but not in the two sets given here. And that is A union B complement. Now, this is how to represent the two-set problem in a Venn diagram. But before I continue, I want to give you a nice way to solve a two-set problem. So in some cases, they will ask you find at least one, only A, only B. How do you go about it? How do you solve this? So before we continue to solve any question, let's look at the formulas for at least one, only A, only B, both. Get it? Okay, so when you've been given a question and you are asked to find at least one, Please, we are still on a two-set problem. When you are solving a two-set problem and you've been asked to solve for at least one, so this diagram we have here, you've been told to find at least one. How do you go about it? So we have the number of A plus the number of B minus the number of A intersection B. And that is the formula to solve for at least one. So let's look at only one. So when you are told to solve for only one, how do you solve this one? So with this one, it is going to be number of A. Please take note of these formulas here. So number of A plus number of B minus 2 multiplying the number of A intersection B. So there is the formula to solve for only one. Now let's look at only A. So only A. So now how do you solve for only A? So only A is going to be number of A minus number of A intersection B. And that is how to solve for only A. Now let's look at only B. So only B is the same as how to solve for only B. But the number of A is going to change. So we are talking about B. So it's going to be number of B minus number of A intersection B. And that is how to solve for only B. Now let's look at how to solve for both. So now both is going to be, so how to solve for both? So that is going to be number of A intersection B. So this portion here, the 2 here, which is A intersection B. And that is how to solve for both. Or now let's look at the last one, none. So when you've been told to solve for none, so let's say none of these students like mathematics. So how do you solve for it? So none. And none, the formula for none is going to be number of U, which is the universal set, minus number of A plus number of B minus number of A intersection B. And that is how to solve for none. So these are simple formulas you can use moving forward. So when you see any question stating at least one, only A, only B, both, none. So there's formulas here. So I took the formulas here from the diagram here. So look at how this diagram is, and this is how you put your formulas. So when you've been told to solve for at least one, only A, both, none, these are the formulas you are going to use. So now let's solve some questions. So we have this question here. In a group of 120 students, 70 study mathematics, 55 study English, 30 study both mathematics and English. Represent your answers on the Venn diagram. Hence, find the number of students who study mathematics or English, the number of students who study neither mathematics nor English, the number of students who study only mathematics, and the number of students who study English. That is only English. Now let's solve. So we represent our information on a Venn diagram, and this is how our Venn diagram is going to look like. So we have the rectangle here and the two sets, right? So the number of students in the class, that is the universal set, is going to be 120. And we denote the number of students who study mathematics by n. So the number of n is 70, and that of English is 55. And 30 students studying both mathematics and English. So we represent here by 30. So the intersection of maths and English is 30. And that is how our Venn diagram looks like. So now let's solve the first question. Now the first question is saying the number of students who study mathematics or English. In other words, the number of students who study at least one of these subjects. And that is going to be, so we have the number of students who study mathematics or English. So now we use the formula here. That is going to be number of students who study mathematics plus the number of students who study English minus the number of students who study both mathematics and English. That is going to be maths intersection English. So we have 70 plus 55 minus 30, right? That is going to be 125 minus 30. So number of students who study mathematics or English is going to be 95. So we conclude that 95 students study mathematics or English. Yes. So that is it. I hope it is clear. Okay. Now let's solve the second question. So the number of students who study neither mathematics or English. Okay, so we apply the formula here as well. So we have number of students in the class, that is the universal set, minus number of students who study mathematics plus number of students who study English minus number of students who study mathematics and then English, right? And that is going to give us 120 minus number of students who read mathematics is 70 plus English is 55 minus number of students who study both mathematics and English is 30, right? Okay, so we are going to get 120 minus 95. And students who study neither mathematics or English is going to be 35. So we conclude that 35 students study neither maths nor English. Okay, and that is how to go about the number of students who study neither maths nor English. Okay, so we continue. So the next question is the number of students who study mathematics. So the number of students who study only mathematics. That is going to be, so that is C, right? So only mathematics. Now only mathematics is going to be number of students who study mathematics minus the number of students who study mathematics and then English, right? So that is going to give us 70 minus 30. And the final answer is going to be 40. So 40 students study only mathematics. So only 40 students study mathematics out of the 70 students. Only 40 study mathematics, right? Okay, so the last one is going to be only English. Now only English, we also apply the formula here. So number of students who study English minus the number of students who study mathematics and then English. And that is going to be 55 minus 30. So we have 25. Now we want 25 students studying only English. And that is it. I believe it is well understood. And that brings us to the end of today's lesson. In my next video, I'm going to talk about a very simple problem and we shall solve a practical question. So please don't forget to like, comment and subscribe to my channel for more maths mastery. I'm Venn. Stay tuned for more maths mastery. Thank you.